Okay, this is the demo video for ENEL384Lab3 on October 1st, 2020. So the first thing I did here was I wrote down the what I needed to do, and then I wrote down the truth table. So we're supposed to be building an indicator system for a 4-floor elevator that uses 2 switches to detect when it's at the corresponding floor. So the first thing what I did after that was I went through each floor, floor 1, floor 2, floor 3, floor 4, and I made up the corresponding logic that would be needed to be able to do it. The indicator outputs are active low. Keep that in mind. And then I figured out the number of gates I would need can be reduced to 6. So then on the next page here, I have the schematic here. So the top 2 gates make the inverted versions of the signals coming from the switches, and then there's some pass-throughs here for the non-inverted versions. Then the bottom 4 here take the various signals and do what they need to do with them to make the various indicators signals. And then you have your LEDs over here connected to 3.3 volts through the 270 ohm resistors, and then the active low outputs of the corresponding signal gates connect them to ground. Then over here you have your 2 switches, so they connect 3.3 volts to the top 2 gates here. And then as you see, the signals are pulled down through 210 kilo ohm resistors. I prefer active low, or I prefer pull down versus pull up. It makes more sense to me. And then over here you have I have the two pinouts of the chips here. So you got your SWS1 and SWS2. Those are the non-inverted signals coming directly from the switch. And then you have your knotted versions of those coming out of the 74HC00. And then the various inverted and non-inverted signals go into the inputs of the second chip down here, and then they come on the outputs of indicator 1, indicator 2, indicator 3, indicator 4. And keep in mind that those indicator outputs are active low. Then I have a color assignment here for for the wires. So your orange is 3.3, black is ground, red is SWS1 non-inverted and indicator 1. Green is SWS1 not and indicator 3. White is pin same connect, and that is just for tying the inputs of the NAND together to make a NOT. And then your blue is SWS2 non-inverted and indicator 4. And your yellow is SWS2 not and indicator 2. So now let's demonstrate our circuit here. Put that aside and bring in our circuit here. So on the board here up towards the top you have the switch here, the little dip switch system here. So the first one and fourth one are assigned accordingly as SW1 and SW2. And then the two switches that are being used are tied down through the 10K bus resistor network here to ground. As you can see here, it's connected to ground through there. Then you got the 2 chips here and there. The top one takes care of generating the inverted versions of the signals, and then the bottom one reacts and provides the outputs for the 4 indicator LEDs. So this is indicator 1, indicator 2, indicator 3, and indicator 4. And then those LEDs are pulled up through 270, the isolated 270 ohm resistor network here to 3.3 volts. As you can see, there's orange, just like I said in the legend. And then they're all connected through the various colored wires here to the second chip. So before I turn on power up the circuit here, according to our logic table over here, or our truth table, have both switches are off, then indicator 1 should turn on. So we'll test if that is true here in a second. So turn on the circuit. So both switches should be turned off. And if we turn on the circuit with both them off, indeed indicator 1 turns on. So now, according to our truth table, if number 2 is on and number 1 is off, indicator 2 will turn on. So let's see if that is true. So down here, I'm about to press indicator 2, and indeed, or switch 2, and indeed indicator 2 turns on. And more importantly, indicator 1 is off. So now let me just turn this guy off. Come on. There we go, and these are very tricky to keep in your board here. Then, according to our truth table, SW1 is on and SW2 is off, and that should make indicator 3 right here turn on. Let's check if that is true. So, turn this guy on. And indeed, indicator 3 is on and nothing else is on. Then, according to our truth table, both are on. Indicator 4 should be on. So let's see if that is true. So I already have number 1 on, so now I need to turn number 2. Number 2 on. And indeed, number 4 turns on. So this means that my circuit works. Have a good rest of your night, Dave.